Hey everyone, welcome back. In this video, we will be going over the statistical interpretation of quantum mechanics as laid out by Griffiths, Chapter 1. And so, in this section, we're going to go a little bit deeper into what psi really is. So in last video, we said that psi of x and t is everything we can know about our system. And so this caveat right here, can know, is extremely important. So we can't, it's not saying that psi will tell us everything about our system, but it's saying that psi will tell us everything we can know about our system. Which, I mean, from like most physics class, so far, this statement doesn't have very much meaning. What is everything we can know? And so we will be developing that. But first, before we can really develop that, we need to take an interpretation of psi. And so we're going to be, throughout this course and throughout Griffiths' book, taking the Born Statistical Interpretation of psi, which says that psi squared of x and t is a probability density function. And with psi being a probability density function, that means the integral, or means psi squared being a probability density function, the integral from a to b of the absolute value of psi of x t squared dx. This is going to give us the probability of finding our quantum object in the range of A to B. And I know Griffiths goes on to talk about the different interpretations, and they're good to know for what really is quantum mechanics. And I highly suggest you read it. But for a computational standpoint, these are not important towards quantum mechanics. They might be important for your professor, so definitely read that section. It's just 2 pages, 1 page front and back. But now we will be going on into probability theory, and we'll be going first through discrete probability and then continuous probability, which we will find to be the most useful. Alrighty, we'll see you in the next video.